My name is Lori Stokes. I'm the silviculturist on the Camp Lick project, and this is the Silviculture resource story. I will be talking about several topics for the project. I'll be talking about plant association groups, structural stages, and species composition of the stands. I will talk a little bit about the historic stand conditions, especially relative to soils. I will cover the insect and disease present in the project area, and finish with some stand management options for the project. Our forested stands are identified by plant associations. Plant associations are named for the dominant forested trees and for the dominant shrubs and grasses in the understory. An example of this would be the ponderosa pine, pine grass, or the Douglas fir snowberry plant associations. These plant associations are then combined within plant association groups, which are groupings categorized by temperature and moisture regimes. Using the same example of ponderosa pine, pine grass, this plant association is grouped within the warm-dry plant association group. This indicates a warm temperature and dry moisture regime. This is the most common on the Malheur National Forest and also within this project area. Several characteristics define the vegetation that drive the plant associations, including elevation, slope, aspect, and soils. Much of which defines the vegetation characteristics are also described in the soils, watershed, and the fire fuels resource stories for this project. They further discussing the complex interactions defining our environment. Listening to these resource stories will give one a better overall understanding of the project area. I would just like to mention here the historical composition, and I will stay focused on the warm-dry PAG as it is the most representative in the project area. Warm-dry forest types have had frequent low-intensity fires. They are often the classic open ponderosa pine stands, to mixed conifer that were still dominated by ponderosa pine but had components of Douglas fir, western larch, lodgepole, and grand fir. Continuing with the warm-dry plant association group, as I said, it is the most common on the Malheur National Forest and also in the project area. 93% of the project area is forested. Forested meaning stands that have at least 10% canopy cover. Of that forested area, approximately 60% of it is comprised of the warm-dry plant association group. This includes most of the ponderosa pine, Douglas fir, and a portion of the grand fir plant associations. This is just an illustration of the locations of the warm-dry plant association groups and all the others, but as you can see, warm-dry covers the bulk of the project area. Past harvest, of course, also contributes to existing structural stages. The project area has had a total of approximately 9,400 acres that has been commercially harvested since 1981. Although there has been no commercial cutting out here since 1994, other than a few units associated with the County Road 18 project, and those are located only along the southwest boundary of the project area and can be seen here in very light blue. The acres of commercial cutting include approximately 3,000 acres of regen harvest, approximately 3,000 acres of overstory or final removals, 2,800 acres of partial removal, 260 acres of thinning, and also some salvage. Volumes of the commercial harvesting generally removed 5,000 to 10,000 board feet to the acre. Harvest in the 1980s, particularly the partial removals, often removed some of the ponderosa pine while leaving the grand fir to be managed as a future crop tree. What you're looking at now displays the dominant species of each stand across the project area. The blues are stands dominated by Douglas fir, the greens are dominated by grand fir, browns are lodgepole, oranges are ponderosa pine dominated, and then the golds and the grays are western larch, with the purple being juniper. As you might expect, the lower elevations of the project area are where ponderosa pine is the dominant species, and as you move up in elevation, up into the mixed conifer, you move into the greens and the blues, dominated by grand fir and Douglas fir. Now this is the same display as the previous slide. In the soils resource story, Hirsch McNeil explained the molic soils and how they are indicative of where open stands of ponderosa pine with grass understory existed. The hash lines here indicate where the molic soils exist, and it overlays the dominant overstory conifer species. As you can see, much of the area of molic soils has a ponderosa pine overstory, oranges with the hashed lines. But there's also quite a bit of area where the dominant species is now grand fir, is green with the hash lines. These areas could be identified as needing treatment to improve resilience on the landscape by moving stands back towards the historic species composition, reducing the grand fir to increase the ponderosa pine. This is a display of the aspect across the project area. For now, if you just ignore the hatching, the blues are north aspects, brown is northwest, yellows to reds are southerly to west aspects. The areas with the hatch mark overlay shows where ponderosa pine is one of the dominant overstory species in the stand. This indicates that ponderosa pine is often currently a dominant overstory species where one would expect it to be, on the south and southwest aspects. These stands should be looked at to maintain this species. This does not show, however, whether the stands are overstocked or whether they might have a fir understory that is not characteristic of historical conditions. This slide again displays the aspect across the project area. The overlay indicates where grand fir is one of the dominant species in the overstory. It indicates that grand fir is a dominant species where one would expect it to be when it overlays the blues in color on the northerly aspects. It also indicates there are some areas that grand fir should not be a dominant overstory species on the southerly aspects. These areas should be looked at to decrease the grand fir to improve resiliency and move stands towards a more historic species composition. Now I will talk a little bit about the stand structure across the project area. The table here displays the stand structural stages across the project area. We do have 23% in Old Forest multistrata, but only 4% in Old Forest single strata. The dominant structural class across the project area is stem exclusion. There's very little stand initiation stands within the project area. The amount that we're striving for is dictated by our historic range of variation that will be displayed next. The HRV for the Warm Forest Plant Association group is displayed here because it is about 60% of the forested project area. It will be where one of our most active management options exist. You can see that Old Forest single story is well below the historic range. Old Forest multi-story is slightly above the historic range, and by our current forest plan direction, it would allow us to treat some of the Old Forest multi to create more Old Forest single story. Other structural stages are all slightly above or within the historical range except for stand initiation, which is below the range. In the warm dry forest, structural stages are seemingly not uncharacteristic of what they should be, but keep in mind this is only structure and does not directly correlate to density or necessarily species composition. This is just a visual display of the structural stages across the project area. You can see that a lot of the old forest is just scattered throughout the project area and is not grouped largely in any one portion of the project area. The next couple slides are pictures of existing conditions out in the project area within a warm dry plant association group. This is grand fir coming in under ponderosa pine, And this would be due to fire exclusion over the past 100 years, and where fire has not played its natural role, which would have kept the grand fir out from reproducing in the understory. This picture is also from the project area. It shows ponderosa pine surrounded by grand fir, and is pretty representative of a lot of stands within the project area. Treatment option here would be to reduce the grand fir to maintain the ponderosa pine into the future. Now I'm going to talk about the insect and diseases that are present within the project area. We have western larch dwarf mistletoe. This is causing a lot of mortality in the western larch. The mistletoe causes breakage of the branches of the tree, and severe infection will lead to death of the western larch. It will also infect the western larch regeneration underneath the trees. It causes brooming in the branches, which when they fall will increase surface fuels. Western larch dwarf mistletoe is at a high level infection within the project area, above what would be the historic range of low levels of infection. We also have root diseases such as armillaria and anosis. These are most commonly found in mid to late successional stands comprised of a high fir component. These root diseases are a natural part of forests, but at low levels. When they become increasingly active in stands now dominated by grand fir, mortality outside of the historic range occurs, such as in the case now in many of the stands. Past management that removed some grand fir but retained much of it left conditions suited for the infection to occur and to spread. Much of the past harvest within the project area managed the grand fir at varying levels, and the resultant root disease is evident throughout. Mortality will continue to occur, increasing fuel loads and increasing costs of treating the area to improve resiliency. There's also bark beetles, both western pine and mountain pine, within the project area. The mortality in the lodgepole pine has been caused by the mountain pine beetle. The mountain pine beetle is currently thought to be decreasing, but has already caused quite a bit of mortality in the project area. One of the larger areas is located right at the junction of the 36 and the 3640 road. You can actually see lodgepole mortality on both sides of the road there. There aren't really any management actions that would be taken to affect the current mountain pine beetle, but stands can be maintained at densities below the threshold for future bark beetle activity. The western pine beetle has also been active in the project area and has caused mortality in some of the large ponderosa pine. There are other insects and disease within the project area, including fir engraver, Douglas fir, and ponderosa pine dwarf mistletoes, and white pine blister rust. White pine blister rust is pictured on the right-hand side of the screen in a plantation. It is an invasive disease that has caused mortality in the white pine that, when coupled with past harvest and pine beetle activity, has caused a decrease in western white pine representation in the area. Douglas fir and ponderosa pine dwarf mistletoe are present also throughout the project area, and they affect the growth of the trees and can eventually cause mortality. Some of the other trees that are within the project area are aspen and cottonwoods. We have documented about 20 known aspen stands within the project area. All of these have conifer encroachment, all have been browsed to varying degrees, and all will be proposed for treatment to help improve the health of these stands and to maintain them into the future. Taking into account the existing conditions of the project area, including the density of the stands, the species composition of the stands, and the levels of insect and disease in the stands, we can consider for treatment areas where the species composition is not consistent with historic compositions, where stand densities are not sustainable or resilient into the future, and where insect and disease levels are high and can be reduced through treatment. Thank you for your time.